Hello everyone, welcome back to my YouTube channel. I hope you all are doing well and good. The subject I'm going to be talking about today is computer graphics and image processing, aka CGIP, bearing the subject code 21CS63. So without any delay, let us get into the video. Firstly, we have the contents, that's the introduction, the type of graphics used, why are computer graphics mainly used, the applications of computer graphics, that is CG, image processing, application of image processing, and finally we have the conclusion. Moving on to the first slide, we have introduction. So, computer graphics. The term computer graphics itself was actually coined by Verne Hudson and William Fetter from Boeing, who were two pioneers in this field. And it is basically defined as any sketch, a drawing, or a special network that pictorially is going to represent some meaningful information. Computer graphics is used where a set of images needs to be manipulated or a creation of an image in the form of pixels is drawn on the computer. Computer graphics can also be used in the digital photography, film, entertainment, electronic gadgets, and all other core technologies that are required. It is a vast subject and area in that field of computer science. Computer graphics can also be used in UI design, rendering geometric objects, animation, and many more. In most years, around graphics is an observation of CG. There are several tools used for the implementation of computer graphics. Moving on to the next slide. We have types of computer graphics. There are basically two types of computer graphics, namely raster graphics and vector graphics. Firstly, we have raster graphics. Raster graphics are also known as bitmap graphics and are images composed of a grid of individual pixels, each with its own color and intensity. Next, we have vector graphics. Vector graphics are going to use mathematical equations in order to create shapes, lines, curves, and other geometric figures. Instead of being made up of pixels, they are composed of paths defined by a start and an end point along with other points, curves, and even angles included. Moving on to the next slide. We have why are computer graphics mainly used. Firstly, we have visual communication, enhanced understanding. Graphics help us convey complex information quickly and clearly, aiding in better understanding and retention. Engagement. Visual elements can make content more engaging and appealing, holding the viewer's attention. Next, we have simulation modeling, that is virtual prototyping and scientific visualization. So virtual prototyping is going to allow us for the creation of virtual models of products, enabling testing and refinement before physical production. Scientific visualization. It is going to help us in visualizing complex scientific data, making it easier in order to analyze and interpret. Moving on to the next slide. We have entertainment, that is video games, movies, and animation. So, video games provide immersive environments and realistic animations, enhancing the gaming experience. Movies and animations used to create special effects and animated features, making scenes more realistic or fantastical. Next, we have education and training. Interactive learning and simulation. So in interactive learning, graphics in educational software and e-learning platforms are going to enhance interactive learning experiences. Simulations. Used in training programs such as flight simulators for pilots to provide realistic practice scenarios. Next, we have art and design, under which we have digital art and graphic design. Digital art is going to enable the artists in order to create detailed and intricate digital artwork. Next, we have graphic designs, essential for designing logos, ads, that is advertisements, and other marketing materials. Moving on to the next slide. We have the applications of CG, that is computer graphics. So firstly, we have entertainment. Again, as mentioned, it's mainly used in video games, movies, and animations, where creation of immersive 3D environment, realistic characters, and dynamic effects. Under movies and animation, we have production of visual effects, animated films, and computer generated images, that is CGI. Education and training, again, interactive learning, educational software and e-learning platforms with engaging visual content. Simulations, training simulations for pilots, military personnel, and medical professionals. Medical imaging, I feel this is one of the most important aspects of CG here. So firstly, we have diagnostics and surgical planning. So in diagnostics, it is visualizations of tools in MRI, CT scans, and ultrasound for detailed internal views. Next, we have surgical planning, 3D modeling of patient anatomy to aid in pre-surgical planning. Moving on to the next slide. We have design and manufacturing, that is CAD, computer aided design, design of machinery, building and consumer products with precision and efficiency, virtual prototyping, development and testing of digital prototypes before manufacturing. Next, we have graphic design, marketing materials, creation of logos, brochures, advertisements and other promotional content, digital art, production of digital work and illustrations. Next, you have user interfaces, mainly that's UI, that's GUI, that is graphic user interfaces, design of intuitive and visually appealing software interfaces, and web design, development of visually compelling and user-friendly websites. Moving on to the next slide. We have what is image processing here. So image processing is that process of transforming an image into a digital form and performing certain operations to get some useful information from it. The image processing system is usually going to treat all images as 2D signals when applying certain predetermined signal processing methods. Here are some of the key aspects of image processing. Firstly, we have enhancement, improving the visual appearance of an object or highlighting specific features. Examples is adjusting brightness and contrast, noise reduction, sharpening and edge enhancement. Next, we have restoration, reconstruction or recovery of an image that has been degraded. Examples is basically removing blurs, correcting geometric distortions and restoring old photographs. Analysis, extracting meaningful information from an image. Example is object recognition, pattern recognition and image segmentation. Moving on to the next slide. We have compression and transformation. So compression, reducing the amount of data required to store or transit an image. Examples is JPEG compression from photographs, PNG compression for web graphics. Lastly, we have transformation, that is changing the format or structure of an image. Examples is resizing, rotating, cropping and format conversion. Example is from BMP to JPEG or rather JPEG. Moving on to the next slide. We have the applications of image processing. Firstly, we have medical imaging, enhancing and analyzing medical scans. Example is MRI, CTs and X-rays for diagnostic purposes. Secondly, we have remote sensing, processing satellite images for environmental monitoring, weather forecasting and resource management. Thirdly, we have photography, editing and enhancing digital photos in order to improve quality and artistic effects. Fourthly, we have industrial inspection, automated quality control by analyzing image of products or production lines. And lastly, we have security and surveillance, that is facial recognition, motion detection and other forms of automated surveillance. Moving on. Computer vision, enabling machines to interpret and understand visual information from the world. Next, we have document processing, scanning and converting printed documents to digital format, including OCR, that is optical character recognition, for text extraction. Next, we have AR, that is augmented reality, enhancing real world environments with overlaid digital content. Lastly, we have forensic analysis, analyzing images and video evidence to support law enforcement and legal proceedings. Moving on. We have the conclusion. In conclusion, computer graphics and image processing are essential technologies that significantly impact various fields, from creating immersive video games and movies effects to enabling detailed simulations in scientific research and medical diagnostics. Computer graphics are going to enhance our interaction with both virtual and real environments. Image processing is going to further support these capabilities by enhancing, analyzing and transforming images, crucial for application like augmented reality and forensic analysis. These technologies drive innovation, improve communication, and open new possibilities across different domains. As computational power and algorithms advance, the potential for computer graphics and image processing will continue to grow, leading to even more exciting opportunities in the future. So I hope you understood all the topics that were covered in this particular video, right from what is CG to even image processing, the applications of CG, the applications of image processing, so on and so forth. So I hope you enjoyed the video. Thank you for watching.